Okay, and all the parts A are a lot easier. All they want us to find is they want us to find a function value at the value inside the parentheses, which means they tell you what the x value is. They want you to find what y is. So wherever you see an x, I put in a value of 8. So we have 3 plus 5 sine pi over 9, 8 minus 11. And as we talked about on Thursday, this is where hopefully you can do some mental math. 8 minus 11. If you need to clickety-clack them through, go ahead and clickety-clack them through. 8 minus 11. But hopefully you can mental math this to say this value is -3. So in my calculator, my suggestion to you is type this in and put -3 as your coefficient to pi. Make sure you're in a radian mode. Make sure you're in a radian mode. Go to mode, make sure radian is the one that's highlighted. So you have 3 plus 5 sine -3 pi divided by 9. Close your parenthesis out. And you should get -1.33. Bless you. Okay, the part A's are just subbing in, and whatever that value inside the parentheses is, tag it along with the coefficient of pi. Make sure you close your parenthesis out. So we have 3 plus 5 sine, oh my, sine -3 pi over 9, close the parenthesis out. And you can type that straight into the calculator and you can get a solution. Part 2 is the one that requires a lot of the work. Given f of x is a value of 2, we want to find our general solutions in the first smallest 3 positive values. So we're being told f of x, which is this value here, is a value of 2. So substituting 2 in for f of x, we have 2 is equal to 3 plus 5 sine pi 9 x minus 11. Each one of these problems are going to be solved the exact same way. The first thing you want to do is subtract your vertical phase shift of 3 over your constant, your value out in front. Subtract that to the other side. So take your 3, subtract it to the other side. And once again, this will be the same each and every time. Take 3, subtract it over. And then you're going to divide by that coefficient of your trig function. Then divide both sides by your coefficient of your trig function. So you divide both sides by the 5. Once again, don't worry about putting a decimal down there yet. You'll take care of that here in a second. Those first two steps in each one of these problems will be the same each and every time. Add your vertical phase shift over, divide by your coefficient of your trig function. Your next step is to get rid of your trig function. Well, we have a sine there. What do we do to both sides to get rid of sine? Nolan? Inverse sine. Okay, so we're going to take our inverse sine. So now you can quantify that negative 1/5. So we have inverse sine of negative 1/5 is equal to finger space pi over 9. Once again, get your finger space in there. Inverse sine of negative 1/5. What do you come up with? Negative 0.2. Once again, it's a very small value. It's a very small value there. So if it's a very small value, inverse sine is going to be equal, or the sine of an angle value is going to be equal to that value. Okay, but when you take the inverse sine, you have two solutions. Just like when you take the square root of both sides, you have to deal with plus or minus. When you do the inverse sine, you get two solutions. You get our calculator value, which we call the principal value. We call that the principal value. But with the inverse sine, how do we come up with our second solution? How do we come up with a second solution, Rachel? Okay, what are we finding? The supplement. Okay, we're finding the supplement. So when you're taking the inverse sine, you have the principal value and its supplement. When you take the inverse cosine, it's the principal value and it's what? Opposite. Inverse cosine, principal value and its opposite. Inverse sine, principal value and its supplement. Okay, so inverse sine, principal value and its supplement. Inverse cosine, we have principal value and its opposite. Well, we have the inverse sine. As Rachel said, we need to take 3.14. Take our 3.14 and subtract off our negative 0.2. Okay, we have the minus negative. Turns into a positive. So we have a minus negative, turns into a positive, so we should have 3.34. .34 plus or minus or is equal to finger space pi over 9 x minus 11. Why do we leave the finger space? What's our next step? What are we going to multiply both sides by? Laura, what are we going to multiply both sides by? 9 over pi. So we're going to multiply both sides by the reciprocal, 9 over pi. That will cancel these out. So we have negative 0.2 times 9 divided by pi. And then we have the 3.34 times 9 divided by pi. Now, if you want to work when you're dealing with the inverse sign, if you want to just work 1 all the way through, take your 9, multiply by negative 0.2 divided by pi, get your value. Then my last step is I have subtraction by 11. I can add 11 to both sides. So you can just add the 11 there to both sides. That would be fine. And then take your 3.34, multiply by 9, divide by pi. Yeah. Go to the office. All right. Thank you. Take your 3.34, you can multiply that by 9, divide by pi, then you can add your 11 to both sides. In both cases, we have plus or minus the period n. Our b value is equal to pi over 9. We calculate the period by taking 2 pi divided by your b value. So we divide by our pi over 9. Get your 2 general solutions, check with somebody around you. I'm walking you through this step by step. You need to follow along step by step and work through it. Okay? So why we're going through this slowly and step by step. You need to keep working at it. Okay, our 2 values that we come up with before we add the period n. We have negative 0.2 times 9 divided by pi. Then we add 11 to that. Braylon, what do you get for the first value here? 10 point what? 43. We're good with 10.43 here, multiplying 0.9 times 9 times negative 0.2 divided by pi. 10.43. Good with that, everybody? Okay, second one over here. Okay, second one, that's after we multiply here, then we add 11. Add 11 to that value. That will give us our 10.43. Our second value, Abby, what do you come up with? 20.56. Good with that value? And if you're off by a penny, don't worry about it. Okay, if you had 20.55, 20.57, don't worry about that. Don't worry about the penny. okay, plus or minus the period end. So we have 2 pi divided by pi over 9, which we flip and multiply, so the pi's cancel out. So we have 2 times 9. So the period would be what, Odessa? I'm sorry, what? 18. So we have value of 18 there. So we have 10.43 plus minus 18n, 20.56 plus or minus 18n. First 3 smallest positive values. Now we can take these values and either add or subtract 18 from them. What's our first value? What's the first value? 10.43, is that our first value? Well, it looks up there, that's our smallest value. Then we have 20.56. How'd you get that? Minus 18. If we take the second one over here, we can add or subtract, and this is what you have to watch out for when you go through these problems. We have 20.56. We can add or subtract 18. If we take 20.56 and subtract off 18, I still get a positive value of 2.56. Then I can come to your 10.43, Sid, for the next one, 10.43, which is this value. Then I can play leapfrog to go from 1 to 3. Take us back to the 20.56. And once again, if you show me this work here and if you're off by a couple pennies or whatever, don't worry about it. Don't worry about that. Okay, and what I have down here is I have 2.58 and 10.42. Okay, so I'm off a little bit from what you guys came up with, which is fine. I might have held a few more values within my calculator as I solved the problems. Don't worry about it. You show me this work, you'll be fine. But once again, you have to have patience as you go through the problems. There's multiple steps that you have to go through. And that's, the thing that's sometimes a hard thing to adjust to for students is just to have patience as you go through the problem. Okay, it's multiple steps to get through it, and there's different avenues that you have to worry about. Okay, when you're talking about inverse sine, do I have inverse sine or inverse cosine? Okay, what do I look at? Principal value and its opposite, principal value and its supplement. Okay, looking at those values, how do I calculate the period? 2 pi divided by b. Am I in x radians or am I in theta degrees? Okay, so those are all things that you have to evaluate as you go through the problems. Other questions that you have? Inverse sines tend to be a little bit more of the difficult ones because you have to deal with the supplement. Inverse cosines tend to be a little bit easier because you have the principal value and its opposite. Okay, you don't have to do as much work there. We will spend a couple days going over these ideas. Can you just hold on? Just let me go through and then get you. Now, what I suggest you do, okay, you take a look at the paper here. Problems 1 and 3 are in degrees. Problems 2, 4, 5, 6, and then 5 and 6 or 7, 8 on the back are all in x and radians. Here's my suggestion. Do problems 1, change your calculator to degrees, do problems 1 and 3. Do problems 1 and 3 in degree mode. Then change it to radians, and then you can go back to 2, 4, and then the rest of the worksheet. So you're not having to worry about the flip-flop and flip back and forth between degrees and radians degrees. You just have to remember after you do your first two, I'm going back to radians. So do your first couple in degree mode, and then go change it into radian mode, and then solve the problems in radian mode. Solutions are provided for you. I think I have a set of solutions also up here. I think I printed them. Solutions are up here for you then. Tomorrow we'll have an in-class assignment that will go to your worksheets. Wednesday will be a review day, and Thursday will be a quiz over this material. Questions? But the worksheet tomorrow, the review sheet, and the quiz will all look very similar to what you're seeing right here. All right, you have 15 minutes. Good start here.